Well, today I'm going to review this FNIRSI product here, the IPS3608, which is a power supply. I believe it's new to the market. They've only just launched it, I believe. It's the first time I've seen it anyway. Let's see what's in here. This is sent to me at no cost by FNIRSI, so this is for the purpose of review. I haven't been paid apart from the product itself, so for a full disclaimer, I know basically nothing about this apart from the fact that it arrived. So, okay, IC connection there, the universal input power, switch on the back. Don't like switches on the back. My pet peeve is a USB port there, probably firmware updates. So we've got a little control pad, rotor encoder, which is push button, couple of buttons there, USB ports here, I guess that's a light, and two terminals here which are just banana jacks. No binding posts, which is a shame because I actually prefer binding posts on power supplies, because it means you just get a couple of bare wires and shove them on, you know. But you can always adapt it, it's not that big a deal, but I prefer binding posts myself. Also they've gone for a sleeker look. I actually have a few items to review. I've got a couple more items over here, so watch out for those videos in the future too. I'll probably do one a week or something. Okay, what do we have in here? Here's some cables for hooking up, sort of crocodile clip leads, PVC leads. Yeah, it feels right. Yeah, it feels solid enough. They're decent grip on them. You plug them in, yeah, they feel good. USB cable there, and a power cable, which is not appropriate for my country, but that's not surprising. A standard IC cable, so it's no problem. I can just plug this straight in here with a standard cable for my country. This is a European one, so that's fine. Doesn't matter. Instructions. We'll look through these very quickly. I'm not going to read it all, so if something you want to read, pause it and have a look. I'm not going to read it. I'm just going to play around the power supply and see what I can figure out, which is exactly what I normally do. I do it by experimenting and seeing how things appear to behave. I like to basically test the user interface and see how easy it is to learn the user interface, which is a far easier thing to judge if you haven't read the manual. If you get things which don't quite make sense, then reading the manual is where you want to go. But I intentionally don't read the manuals. I do it for a reason. So people say, oh, read the manual, you know, RTFM. Well, yeah, I mean, sure, if you want to learn how to use it properly, read the manual. I don't want to learn how to use it properly, I want to learn how to use it by learning how to use it. If that makes sense. Right, that's that. I hope you read that. I didn't. Well, let's power this thing up and see what happens. Power cable's plugged in. Let's power it up there. Switch on the back is still turned off. No power drawn. Let's turn the switch on. It's drawing 8.6 watts. 9 watts maybe. Looks like it's booting up. Select the device language. English. That's easy. And there's the screen. So something I'm just noticing, I'm just going to plug this in, which is a high quality Pomona cable. I'm just trying to plug this in, and I actually can tell that this spacing isn't quite 3/4 of an inch. Because it's actually wanting to push the cable apart as I push it in. That's very slightly bigger. So I think they've actually got the spacing at a metric interval, which has been rounded up by a millimetre or something. It's very slightly off. So I'm going to push it all the way, and it's going to push it in far enough to get it to work, so I'm not putting too much stress on my connector. So it sounds like I got that very slightly off. Right, we've got no voltage right now. So how do we turn this on? Run. Here we go. Run. 10 volts output. 10 volts. It's actually looking pretty accurate too. That's good. Right. So how do we change these things? Graphing. Different screen layouts. Oh, nice. Volts, amps, okay. No. So you have to use the cursor to change it, that's fine. Right, 8 volts, let's go down to 5 volts, see how accurate that is. Oh, sorry, it's 6. 5. That's looking pretty good. 1 volt. Bit lower, bit off there. Half a volt. Yeah, it's not too bad. 100 millivolts. Still sitting slightly. Oh yeah, it's not too bad though. It's alright. Okay. do say 15 volts, another common voltage. It's basically bang on. 20 volts. I don't even know what the specs are on this thing. I'm not sure what voltage you go up to or anything. 20 volts is bang on. 24, another common voltage, bang on. 30 volts, yep. Goes up to 36 volts, and that's bang on. So that's actually looking pretty good for voltage. Okay, let's wind this back down and say, let's do 10 volts again, so it's easy for calculations later on. VA, so amps. Let's go over here where maximum is 8.2 amps maximum settable. Nice. So the milliamp settings on these things. Nice. It's pretty precise. Of course, we have to test see if it actually does those things. On the surface, it looks good. So that's just doing volts, amps, and that's it. Got an internal temperature display just here, 23 degrees. Capacity testing as well. It's got memories. Not quite sure how to do all these things. Actually, let's go here. What we got? There we go. Data sets, so you can do presets. System setup. Okay, let's get a different camera view. Let's have a closer look. Also, I didn't know if you noticed or not, but this went green when it's outputting power. So it's red when its power's off and green when the output is turned on. To me, it's almost like it should be the other way around. Red for danger, green for safe. You know what I mean? So to me, I think really green should be output is off, red is output is on, or even just having this button light up. So yeah, I mean, once you understand how it works, it'd be fine. I just think it's kind of a little bit backwards. Let's try and get this popped up more so it's a bit easy to see. I do still have the protective screen on there, protective film. I'm not going to take that off yet. Display moves around, that's interesting. Okay, so English is already set. It's got 100% brightness preset, 100% volume. The beep isn't very loud, so I'm not too worried about that. Metering switch closed, device address, dark mode. So how do we go in here? Push that. Power. Okay. Let's do that. Light mode. Okay. Exit this. I'm not sure which one's better. I think it's just personal preference in this case. I actually think these are easier to see in light mode. Yeah, I think light mode's probably slightly better. I'm having to hold it because I've got the thing lifted off the bench. It's trying to slide away. So, right, we're back to dark mode. Okay. Metering switch open and close. Don't know what that's for. I have to figure it out. Okay. So let's go back one. About the device. So version 1.3 software. I think that is the version that's currently available on the website. This screen moving around is definitely interesting. Why does this move around? It's just disconcerting. Does this tip out or something? It does. It's an adjustable screen. You can tip it. Huh. Okay, so if the thing's on a shelf or on your bench, you can adjust the angle to make it easier to see. I've never seen it before on a piece of test equipment. Ever. So if it's on the bench, you can tip it backwards a bit so you get the better angles on the screen. If it's up on a shelf above you, you can tip it down. That's really nice. I actually got it like that. That is unique. I've never seen that before. So it probably means I don't actually need to prop this up anymore. So I can just tip it back a bit. And try and get the reflections off. There you go. I think tipping back is giving you can see the difference in display brightness and clarity with the angle. So when it's facing towards the camera, it definitely looks a bit better. So we've got this screen, which is obviously showing a graphing option. Is there anything we can do in there? No. Doesn't seem to be. It's got adjustable settings for the graphing. I don't know what TB stands for, but to me it should be divisions or something. I don't know. Time per division, I think it should be TD, shouldn't it? So you can adjust that graphing. That's nice. Obviously right now I'm just outputting a constant voltage, so it's not really showing that much. 0.5 seconds maximum, 0.1 seconds minimum. Alright. Anything else we can do here? Stop. Oh, I pushed that button, it stopped it. Interesting. Run. Why does that one stop it? Curious. So you can control the settings in here. Okay, so you've got nothing selected. That'll stop it. Won't restart it. And if you have one of those selected, you can change them. So in the graphing page, you can adjust these levels as well. Okay, that's nice. That's convenient. Something you can use this page as well, just fine. Can we do it that way? Yes, we can. And does that do nothing? No. Okay. Gradually figuring this thing out. Deselect those. And back to this page. So this is a different page again. So A and C is these two ports. Monitoring those two. So this is doing the USB ports. So okay. So this one here is the main ports, which we know about obviously. Graphing of those ports, and then we got a readout for these ones. They both say no. Do I have to read the manual for this one? Okay, interesting. So that is only controlling the main channel. It's showing the main output down the bottom here as a sub display. So I want to try and figure out how to adjust these ones then. You'd think you'd be showing a voltage, wouldn't you, if the output was on? Curious. I have to figure this bit out. So I've got my thermal camera here. I'm just going to plug in this cable and see if we can see any response on the display there by plugging in the USB-C device. It is charging. And here we go, USB-A, voltage is now displaying, and so is the current. So it only displays the voltage when it's got something plugged in. Maybe it only displays something once it's negotiated a voltage. It's definitely interesting. So that's working, and it's charging my camera. So it also came with this cable, which is actually quite a nice silicone one. I've actually got some cables a bit like this myself, but I wasn't sure about the quality of them. Cat's trying to kill stuff. So I've got this USB-C cable here, which I was supplied. I don't know if it comes with a power supply, whether it's from something else, because I got a whole bunch of things from FNIRSI at the same time, so I'm not quite sure which thing it actually comes with. Anyway, we'll plug this one in. So that's that USB-C cable plugged in there, and that is not charging. Let's change it around this way, just in case the plug orientation matters. Sometimes it can. Not that time. So around there. And no. So the USB-C cable won't charge my thermal camera. It's obviously looking for power delivery devices only. So that isn't going to do it. Got this Shannon tweezer. I haven't charged this up for a little while. Let's try plugging this in and see if this is going to do anything. Let's try this one. Yep, charging. 150 odd milliamps. Apparently battery is 60%. This definitely could use a charge. But yeah, not going to worry about that right now. Let's try another cable. Just in case a different device will work. You never quite know. No. No, so it must require a power delivery device then. That's what it appears to be like anyway. So let's open this up. Haven't looked at this yet, I only just opened it myself. Ooh, nice. So I'm doing a review on this. It's the HS02A. But what I want to do right now is plug it into this USB cable and see if it will try and charge. Or try and power it, or whatever it will be. Don't think it's got an internal battery, but anyway, let's try that in. Nothing yet. That is also not doing anything. Okay, let's try another cable. Just in case that cable's no good. Here's one of my own USB-C cables. We'll try it on here first. Yes, that's doing something now. That's charging on this one. Right, so that cable here is not working on my devices now. Is this cable bad? Possibly. I did get a cable like that before and I wasn't happy with the quality of it. It wasn't from FNIRSI, it was actually purchased off AliExpress. So USB-C into this. Still not running. Still not work on that one. And so it did work on this. Turn it back off. And let's try it on the soldering iron. That's showing power delivery. Yep, cool. Complaining because it doesn't have a soldering iron tip in it. Oh, it does have a soldering iron tip in it. There we go, now it's working. Right. So it is indeed working. 20 volts power delivery output. Nice. So if you want a power delivery power supply and you want to see what the currents and stuff are without having to use one of those USB meters and stuff, this could be convenient for you. And also you can see the power delivery mode here as well. It displays that on screen too. So let's actually try using this soldering iron for a minute. I'm not reviewing this yet, we'll be doing that later on. This is now heating. 2.8 amps. Yep. Still heating. Okay. So that's drawing 2.8 amps through there at 20 volts. So what's that, about 60 watts or so roughly? Not going to work it out, but yeah, okay, that worked. I'm actually fairly happy with this. This seems to work quite nicely. Now we need to load test it. It's no good about load testing. You also need to check out some things like noise and what have you. See how noisy it is. That's the cat. It's not. You can't help that bit. Well, the internal fan is turned on. That's interesting. Because it finally warmed up enough after doing that little test before. So I've got my electronic load hooked up through these cables here. And we're just going to do some basic load testing. That is actually concurring with what this multimeter here is saying, voltage wise. So that's all good. I'm going to do electronic load, just do a few little tests on it. We'll just see how the power supply handles that load. Yeah, see the voltage drop on this, because I'm measuring really at the terminals here. So I'm going to start with 1 amp. So 1 amp, almost no drop. That's registering exactly 1 amp too, that's really good. So 2 amps. This power supply is rated at 285 watts. So I'm not quite sure if that's a combination of what it is across everything or if it's overall. 285 watts regardless of what you're using, or whether it's split across the channels and it's, you know, like, I don't know, 20 watts allocated to that and 5 watts to that, or whatever it may be. So that's 2 amps, and our current has dropped because we've got the setting here. So let's go here, wind this up. In fact, let's wind this up to maximum, which is 8.2 amps, so it doesn't limit us anymore. So current limiting worked, obviously. That did indeed work. So 3 amps, voltage drop still minimal, that's good. 4, still reading really accurately, minimal voltage drop. 5 amps, yep. Drops a little bit here now, but it's still not much, that's fine. Just leave it sitting for a second, see if it drifts downwards. No, it's looking pretty good actually. And that's 8 amps it's set to now. So it's basically maximum current. And that seems to be doing fine. Okay, let's try 8.1. 8.2, it should current limit, here we go, and gone off. And it's actually shut itself down. So I probably have to, it's actually turned off its output. So I'll turn the output back on again, now I've lowered the current. And it's back on again at 6.9. There you go, back to 7 amps. So that's working fine. I'm pretty happy with that. So let's try, so that's 80 watts then. Let's try increasing the voltage. Let's do 30 volts. 30 volts. And we'll leave it at maximum current. Right, so that's currently doing 30 watts. As you can see on the display there as well. So we'll do the same thing again, 2 amps. Bit more of a challenge for it. So 6 amps, 8 amps. Voltage drop again is minimal. Doing 240 watts, 8 amps. that seems to be fine. Okay, I think we need to check for noise and stuff. So here is the scope set up. I've got cables here running to my electronic load and things like that, so I'm going to be picking up a lot of ambient noise as well. But the noise right now getting is about 64 millivolts with the output turned on at 30 volts. If I turn the output off, it drops down by quite a bit. So we're still picking up a lot of ambient noise. This would be like 50 hertz noise or something, maybe. Or maybe not. There's still some other switching noise going on. That's quite interesting actually. So that is actually quite high frequency noise there. It's like 10 kilohertz still sitting there. So that's quite interesting. And it's about 140 millivolts with the output turned off. I turn the output on, and it goes down a bit, 81. So that's interesting. What I might do is turn the output off, turn my load on, because that would be trying to, yeah, there you go. So turning my load on, cut that down. So it could actually be from my load itself, which is generating that noise. Let me disconnect my load, and we'll see if that improves things. So this is without my electronic load plugged in. That's purely the scope and the power supply, nothing else connected. And that's using a BNC cable, right? So that's shielded and everything. So that's actually the idle noise. That's what it has when it's not actually running. Yeah, it's interesting. Okay, turn the output on. You see a big spike there because it's AC coupled. We'll actually look at this in DC soon and see what it actually does. And that's it again without anything on there. But the output turned on at 30 volts. And that's doing 68 millivolts peak to peak. Or 70 millivolts peak to peak. So not too bad for switching supply. Okay, let's plug my load back in again. And we'll retest this. That frequency there. It's about 90 kilohertz or so. And that's with the power supply with the output turned on with no load on it. If I turn the load on, 1 amp. Still looking there. Okay, let's wind this current up a little bit. And see how bad the noise gets. It's at 4 amps, 5 amps, 6, 8 amps. That's basically maximum output. 400. So it's at 238 watts. So you basically, you know, it's the maximum you want to do. And we're getting about 200 millivolts of noise there. Fan is turned back on again. It is nice. It's got a temperature control fan, but it's either like off or on though. It's not like a variable speed. But you can see the noise difference there between no current, full current. It's quite a big difference. So 200 millivolts noise. And if you put some capacitors or something on this, it might actually help quieten it down a bit. Let's see if I can whack a capacitor across there. Something sizable. Alright, it's 2200 microfarad cap. I'm going to stick this straight across the output and see if this helps or not. There we go, look at that. Sticking the cap across the output did indeed quieten it down. That's just holding it across the terminals. Put the load back on. There we go, 100 millivolts. So no capacitor, with capacitor. So sticking the capacitor across the output does quieten it right down. So you need to get into quieter levels. Stick some more capacitance on it. It looks like it doesn't have a lot of it inside. So yeah, let's do single shot power supply capture. So just turn the power supply off. When I turn it on, it will do a capture of the input voltage and check for like an overshoot. We'll see if we get anything. Look at that, it's actually ramping up. That's with no load on it. So one thing you have to worry about a power supply is we're going to like overshoot and give a big voltage spike. But this seems to be ramping up quite slowly. It's taking like 5.4 milliseconds to rise. So that's relatively gentle. That's good. And what we can also do now is check the falling side. So it's looking for when it goes back down again when we turn the power supply off. I might actually reduce the time base a bit more. Give us more time. Yeah, that's what I thought, was quite slow. Because there's no load on it right now. There we go, just a night slope straight down as you'd expect. So that's looking fine. So the next thing I want to do is look at what we get when we turn the power supply on. So what I'm going to do is put this back to rising. I'll put it as a normal trigger instead. And I'm going to basically power it down. So I think I'll power it on. That should give us a rising edge like that, normal, okay. Now I'll power the thing off. And then I'll power it on again and see what happens. See if we get any weird spikes. I don't think the output will be turned on in the way we left it, or whether it's we have to manually turn it on. Booted up, power supply is in the off state. So there's like no spikes from powering it up. Initial power up will then cause an update, hopefully. So power off, power on. No different. Let's stick a load on it. Let's stick on 8 amps. Power it down. Power it up. There we go. There's a slope of 8 amps on it. So I'll do it again. There you go. So I've got a tiny little spike just over here. And then it ramps up. There's a little squiggle at the end there, but it's like almost nothing. That looks insignificant. So that actually looks fine with 8 amps. Switching 8 amps on full load. So if I do a lower current, let's do say 3 amps, do the same thing again. Powered on, there we go. Little couple of little wiggles in there, but that looks absolutely fine. That looks really well controlled. So the only thing really is it's a bit noisy, but as far as the current control and like the voltage outputs and stuff, that looks good. No over voltage spikes. It's well controlled. Nice. So it's actually doing alright. I mean, you can see my connections here, how that's set up for that test. BNC cable going off and the cables going to my electronic load. So, and the scope was on 20 MHz bandwidth as well, which is what you're supposed to use for that. So that actually works alright. Performance wise, it seems to be pretty good. Noise was quite high. I mean, I would like to see the noise about a tenth of what it was. But it is a switching supply, so you are going to get more noise. But as I said, you could do something with that yourself by adding more filtering. Maybe you can tack some inside. We should pull it apart and have a look. One thing, this fan goes for ages once it warms up. You can see actually got a fan symbol there too. You can see what's doing. Temperature says apparently it's 31 degrees in there. And its fan's still running flat out. So if you're in a hot environment, you might find this fan's running because it's warm anyway. Something to watch out for, I suppose. So the fan shut off at 29 degrees. So I think at 29 degrees, 30 degrees is when that threshold is for the fan kicking in and out. Well, let's take this thing apart. I've got no idea how to take this apart yet. I'm just going to pull screws out and see what happens. There's a self-tapping of the plastic screws. The casing's still warm actually from the heat, from the trials we're doing. Those tests. That moves. Okay, that's wanting to come out. Here we go. So there's a rear panel. Okay. It's a rear panel, so the fan is really easy to get to replace that if you want to replace that with something quieter. Okay. Power supply, switching power supplies right there, at the bottom of the casing. So that's what those screws here are before. Those are for removing the power supply. This one looks like it sticks out more than the rest. Interesting. Okay, and then we've got the front panel at the back there. So I shall see if I can slide all this out. I'm working it will slide out the front. Okay, let's take these ones out. It's like quite simple construction, quite effective. So I think this will now move around, maybe. Will it? Yeah, a little bit. You get a plastic spudger in there. So that moves, there we go. There's the front panel section. And there's an S parts put together. So there's the front panel. Got some caps there on the output. Like I said, I think I could use some more. There's a fuse there, nice. Inside a holder, good on them. It's inside a holder at least, it means you can just plug a new one in. Okay, it's got a couple of sockets on the board there as well, which aren't used for anything, it seems. Right, let's get this power supply loosened off as well and slide that part out. We'll have a look at the whole thing. Same screws, well at least same size screws, not exactly the same, these are different, these are machine screws. Now the power supply in this will be charged. If you ever power one of these things up, you've got a switch mode power supply, which is what this is. There's still likely to be power inside it. So if you ever do anything like this, make sure you're very careful. because you can actually electrocute yourself off the charged capacitors. So I'm doing this because I kind of know what I'm doing, kind of. So let's just see if I can slide this whole thing out. Alright, so here's the casing, all nice, and there is the whole thing. Very nice. So what caps are these? CA? Is that CA caps? Don't know, not a brand I recognise. So I don't recognise that brand of cap. 450 volt PFC, power factor correction. Very nice. So there's the board which has got the switches and control on it. Adjustment there, probably your main output voltage control. And there's the output bolt caps for the power supply itself. So input bolt caps, output bolt caps. So it's got the main AC input over here. Now there is a ground pin here that is grounded. Going to that ground pin on there. So let's actually quickly check something here. So something I've noted here, didn't actually have a ground wire going directly to the casing. It's best practice on something like this, because it's anodized as well, is actually have a wire attached direct to the casing itself. This didn't have that. So I'm a little bit interested in this part as well, because safety is the thing. Right, resistance mode. So let's go from the earth pin here to this heatsink. It's not a great connection because this is an aluminium heatsink and it's got a bit of oxidization on it. That's what they do. It's natural for that. If I give it a bit of a scratch and dig in with the probe, and the same one here as well, here we go, 0.08 ohms. So that itself is fine, but it's relying on contact between this sliding into a slot in this casing, right? It just sits in there, and obviously those screws will screw through here, was attached to it, but it's still anodized, right? So that's actually like a layer of insulation, effectively. If I go between 2 points, I'm touching the casing, 2 places. Look, see, probe's there, no resistance, right? Because the anodizing forms a layer preventing you from getting a contact. See, nothing there. So unless this has got a really good connection to the casing may not actually be earthed. So that's a small consideration, which is why usually it's best practice to have a dedicated earth wire go to a dedicated point on the casing which isn't anodized. So it could be like a welded stud or something on the casing which is welded on, or it could be like a brass stud or something like that, and then that'll be a decent connection to the casing. Right now it doesn't seem to have that. Bit of a fail there electrically. Electrical safety, yeah, marginal. If there's a failure of this board, it's probably going to be okay because it's basically surrounded. So like this board here, the heatsink's right around it. So this is brass studs into the aluminium, right? So those screws on the casing are going into these brass studs. You're going to those. So that itself is probably a good thing. That goes through then to the circuit board. So in a way it's kind of bypassing the aluminium. So that actually improves it slightly. It's one less layer of insulation because of the oxidizing effect of the aluminium. So from the earth pin to a brass stud which goes to the circuit board. Yeah, that's fine. Right, that's actually really easy to get a decent connection there. So the brass stud has got better earth than the heatsink has. See, heatsink, not great. Brass stud, it's fine. The screws that are through the casing going to those studs will be fine. But the question is really going to be, how good is that connection between the screw and this casing? I'm probably being a bit fussy about this, but it's electrical safety, so these are the sort of things you have to consider when you've got a mains powered device. Let's have a close look at this front board. So it's a version 1 PCB. The main power coming in here, 48 volt supply, look, 48's coming in. So you've got some extra filtering here. Well, these linear regulators or MOSFETs. Upside down so I can't tell. Hold on, let's get closer. Looks like MOSFETs. Yep, MOSFETs there. Doing switching. So what's probably happening here is these main MOSFETs are doing the switching for these outputs here. Although you've got these MOSFETs down here too. So that could just be doing local regulation maybe. I don't know, it seems a bit bulky for that. There's another fuse just there too. inline fuse. So the main 48 comes in, goes to a 10 amp fuse that's there for protection. That's 480 watts potentially. That's fine. And then down here we've got some precision resistors just there, current sense resistors. And then you've got some more MOSFETs down here, and there's the output terminals, and there's a fuse there. A 15 amp fuse. So that's a pretty big overhead. Down here, those are the USB ports. Got some current sense resistors on those ports, which is nice. Got some more filtering here. Probably got some switching around here somewhere. Controller, which has been hidden. Little buzzer there. So I mean, it all looks fine. All looks nice enough. Little linear regulator up here. Another one there. Another MOSFET. There's the flex to display. KND3308A, not sure what that is. There's not probably another MOSFET. But the fact it's got these little surface mount fuses in places and replaceable one at that, that's nice. These are, what branded caps are these? Chong X, okay. You quite commonly see these Chong X caps. I don't think they're that bad, to be honest. I think there's enough of them out there to be okay because they seem to be quite widely used. So they're probably not the worst of the worst or anything like that. But anyway, that display board looks nice enough. It looks like it's well designed. But the fact it's got fuse holders, at least a fuse holder there is nice. These have probably got local protection built into those chips anyway. A main fuse there in case something goes wrong with this main switcher. So I'm guessing that it's switching maybe in 2 stages. Like a main primary stage, which is a big, like a coarse tuning, and you've got a fine tuning through those ones, maybe. It's possible, isn't it? I'm guessing here. I mean, you could probably work it out more. Not much on the back there, you can see through there, so nothing there. And obviously the main power supply, which you did kind of look at a little bit before, but not very well. You got some extra ports here. 2 connectors, not populated. So I'm guessing that means those are probably cooling fan control. And they could be. The actual cooling fan that's in here is kind of this rear PCB, which has got the USB port on it. It's running from this. So the front panel here is controlling the fans, as you would expect, so the microcontroller's doing that. We've got some seal pads in here, well, seal sleeves for insulation. There's a seal pad on that diode there. Just looking at this though, there's a nut on there, which is fine to hold it down, that's absolutely fine. There's no signs of any thread lock on that, so if that were to vibrate loose from thermal effects, because it's normal, thermal effects will cause things to gradually loosen off. Having no kind of thread lock on that bolt could be a problem. That could gradually work loose and that will fall off and short out the power supply. So I think it's probably a good idea to put some thread lock on that. So I think it's a bit of a failing there. I mean, you could kind of say the same for these as well, but it's less likely to happen to those because they've got a bit of give because of the pads on these. Yeah, I'd like to see thread lock on hardware inside power supplies. I think it's just a wise thing to do. Yeah, all looks alright, really. It's not too bad. The fan is very noisy, but that looks like a 40mm fan or something. Maybe 60mm fan. So this fan here is a 50mm fan. 50mm. A bit more unusual. It looks like you could probably replace that if you really wanted to. This screws in from the front here. Right, so you could just pop a new fan on here if you really wanted to. Plugs in, so it'd be easy to modify it to put one in. If you wanted a quieter fan, you could do that. The fan is fairly noisy in this. And it was also quite slow to change the temperature inside the device. It took a while to kick in, and it took a while to actually go back off again. So I think the actual cooling across the heatsink itself probably isn't optimal. I mean, it's got these vents on the side which are covered up, which is right by the heatsink. I mean, really, those should be open, or like a filter material or something, so the heat can get out from there. This bit here looks almost like an afterthought. Thinking, oh, we need to let the air out, but they couldn't use these because the holes are too big, maybe. I don't know, it's almost what it feels like. But, I mean, it's a nice design effect, but really you don't want the heat to come straight out. I'm probably just being a bit fussy about that. But there's no real, like, airflow past the heatsink. That's kind of what I'm trying to get at here, is that you've got the heatsink in the casing like this, and you've got this at the back of it, and you've got the vents at the top. Right, the vents are along the top here. So the airflow is going to be going out through the top, or in through the top and straight out the fan. It's kind of not really passing past the heat sinks. It really kind of needs like a vent in the bottom, so it's at least it's trying to run through the bottom of the case, or sucking around the sides from the bottom. Yeah, I think that's kind of a mistake. I mean, it's got a vent here, one side, so that'll probably be helping a bit, but that's probably more for this one, because that's on the front edge, so it's probably more to get heat around here out. You know, exactly right. This is a hole with a mesh in it. That's exactly what you want, but that is exactly what we want down here as well. Could be better, but I think if you're probably not running this thing flat out, you're not trying to hammer it with 8 amps or something all continuously, I think it'd probably be alright. I mean, it looks okay. This power supply does look okay. It's just a few things I think could be better, you know? It's just a few little tweaks that could be improved upon. Yeah, so I think that fan will call this okay, but it won't really call this okay, and this is the bit which probably needs it more. I mean, those MOSFETs over here shouldn't really get that hot because they're MOSFETs, right? Because it's basically a piece of perspex on each side, alright? Seriously, I'd be really tempted to take those out. Yeah, I'd be really tempted to take those out and get better cooling by the heat sinks themselves if you're really worried about cooling. If you're going to be running it hard, it's probably your thing to do. This is grounded anyway. This is earth, so if you do stick something through those vents in the sides, it's okay. It will be probably better to have a mesh there though. Some kind of mesh so objects don't drop in, like, you know, bolts or screws and stuff can't get into it. Probably do want some kind of mesh there to protect it, but yeah, I don't know. I think I'm just being fussy. So for completeness, I've got one screw in here currently loose. I'm going to probe from the earth pin to the casing on the inside, so I'm scratching outside, and see. Yeah, see, there's nothing, and that's where that screw loose. So let's turn up. This is one screw. We'll do it one screw tight. So there's no other screws in it apart from that one right now. Trick it again. Still nothing. Alright. If I try and penetrate the coating, mega ohms still. So that screw isn't actually earthing it. Let's put the rest of the screws in and we'll see if it changes anything else. These front and rear panels, they won't do anything because they're plastic anyway. There is no earthing through those. Okay, let's put our screws in there and tight. Let's check it again. So earth pin on the power supply. Earth onto the case. Trying to push really hard, penetrate through the oxidization. Yeah, 0.17. If I'm just touching on it like that, it's not earthed at all. Look at that, nothing. So it needs something to go through that coating. I don't know, maybe there's a way of like doing this nicely by getting in there and scratching that. You know, let's get a screwdriver in here, scratch around that layer to expose the aluminium. Like that. See if this is any better. Touching the casing. Getting a little bit. Just trying to do something. If I penetrate into through the layer again like I was doing before. 25, push a bit harder, there you go, 0.07. So that's as good as the studs we were getting before. So yeah, the anodizing is a problem on these things. It's an insulator. Right, so I've just done the same thing to all four of them. I notice this one here is actually not bedding in. This one's sticking out slightly. It wasn't before when I even pulled it apart, it was sticking out a little bit. I can actually push it inwards. That's not actually secure. Something's a bit weird about that stud going into that board. It's almost like it's a different depth and thread or something. You can't screw right in. It doesn't go right down. It's a little bit weird. I'm pretty sure it's not the screw. It's changed screws. Yep, still the same. So it's still... That stud is not the right depth or something. I don't know what's going on there. But the screw doesn't actually work on it. It doesn't hold it down. Bit of a design flaw there, it seems. I mean, at least like that, I'm comfortable now that this is actually an earth casing. Before, it really wasn't. You wasn't really getting sufficient contact through these screws. You could argue it's probably fine, but... And I'm probably being a bit fussy. Reality is, it's electrical safety. You have to be fussy about electrical safety. But yeah, anyway, we'll put these screws here back in again. You can probably see what I mean now about the cooling. In fact, the cooling is up here and the fan is at there. Right, so it's just sucking it straight from the cooling here, straight to the fan there. There's nothing actually going directly past these heat sinks. It should be going past them. So, you know, even if it's on one side, if I just open up the vents here, so it's going past the heatsink on that side, that would help because it's aluminium is going to conduct a lot of heat quite well. Even if it's going cooling on one side, it'd be something. So I think it's insufficient as it is. But anyway, if you really wanted to, and have one of these power supplies, you could modify it. Say put some mesh in there instead. Take the perspex out, put some fine mesh in, so something can't just drop straight in. Still needs some kind of protection. That would make a difference, I think, to the cooling efficiency. Allow it to cool down faster as well. Because it did cool down quite slowly. That would be why. The only place where the air is going to get sucked through correctly is through here, through this vent right there. And in fact, something I'm noticing here. I'll take this cover back off again. Just notice something I'm thinking might be a potential problem. So you got this big inductor here, these windings. This actually looks like it's touching in the vent there. So the windings are actually there, pressed up against the side. That's probably not good. I'm trying to tell what the actual mesh is that's in there. If that's plastic, it's probably alright, but to me, this inductor is way too close to the edge. Can I push it over? Maybe a little bit. That's pushed in a bit now, so it's not actually quite so far over. Yeah. Yeah, that's in further now. Right, so it's probably now not going to be touching the side. I'm going to put some sealant or something on that to hold it in place. It should have had some from factory. So that is something which should have been done by factory, I think. That should have been glued down. So that cannot shift that way. Then when it's like that, bend these back up again, get them out of the way. Yeah, that's not touching the side anymore. No, I'm happy with that. Now there's actually a gap, so that's fine. The one thing I'm thinking actually as well, looking at this more critically, we've got these wires here. When it is put together, these wires are laying down this way, and right here all these sharp pins from the connectors. Alright, see those pins sticking out? So when you put it together, those are laying down across those connector pins. I'm going to show you or not. Move this out of the way. See that when it's pushing in, those are wanting to go down through there and rest against those. So it could actually potentially pierce the insulation on these wires. So that's also something which is a bit of a mistake. That should be sleeved to protect it. I'll show you what I mean. And I could have either put some sleeving over it, or I could have got some of this, like this wrap stuff like this. Fabric wrap, which is what I'm going to do, and just wrap these wires to protect them, so that if it does rub, at least it's not going to be rubbing through the insulation. It was far less critical. No chance of shorting those wires out and potentially shoving, I don't know, 48 volts through to the USB ports if it does short into those pins, because I'm pretty sure that would be bad for whatever device you got plugged into it. Okay. A little bit of care. That's now wrapped. This one I'm not worried about, it's out of the way. This one here I'm marginally concerned about, but I think it might be okay. I think these aren't really going to get pushed against it, so that is now much safer. I'm much happy with that. But I shouldn't have to do that. So my opinion on this thing. Firstly, don't forget to click the like and subscribe if you like the review. Functionally, it works quite well. Output was good. It performed. Obviously, I don't know how it's going to go long term because of the cooling. It may not have sufficient cooling to do a high current for a long period of time, but it certainly seemed to be able to produce the output which it claimed to be able to produce. Convenience having the USB ports on the front, that's brilliant. I really like that, and displays, that part I really like. These ports say weren't quite 3/4 of an inch apart. There's very slightly wider, not much. So I think they got them 20mm apart. Cooling could be better. I didn't like that part too much. The cooling could be improved further. That little wiring glitch which I just mentioned with that rubbing on the front panel, that could be improved. User interface is nice, I quite like that, and it seems to work quite well. So really, I think it's a good power supply. I quite like it. Now, normally I'm quite critical of things. I mean, obviously the other thing is as well the noise on the output switching. There's quite a lot of noise there. If you really wanted to, I think you could actually improve that yourself by sticking some more capacitance in it. I think that's something that might be something you could do if you're a bit of a DIYer and you want to try and get that noise level down and get a cleaner output. Stick some more capacitance on your output, stick like a ceramic capacitor across there. It has to be high enough voltage to be able to handle that 36 volts, plus little spikes you may get from things you connected to it. So you probably want like a 50 volt plus ceramic cap on that, electrolytic cap as well. Stick some more capacitance across the output. That'll get those noise levels down a bit further. I mean, you just saw there is filtering there, but it looks like it just needs a bit more capacitance just to quiet it down a little bit more. Your circuitry may or may not care. It may not matter to it that it's got a bit of noise on it. It depends on what you're using it for. You may even find that the stuff you're powering with it will help bring the noise down because it's got internal filtering as well, which will help to backfeed and smooth it out. The noise is higher than I would like to have seen. The wiring here, those bound jacks, inductor on the side there, touching the side, for not being glued down. It should have been glued down. The things wrong with it are just small things. They're all really minor little things. And a lot of things, as you saw, I fixed the wire myself. I fixed the inductor myself. The noise you could fix yourself if you really wanted to. You shouldn't need to though, that's the thing. I think for price, it's actually okay. It's not bad at all. If your budget's quite small, you don't want to like something like this thing here. This beast, this Siglant I've got over here. This thing is considerably more expensive than this. But it is 4-channel. But it doesn't have USB, which this thing does have, which is a benefit. That's very nice to have the USB ports on the front. As you can see on mine, I've got a USB adapter sitting here, so I'll plug a USB cable in and then I can monitor it to achieve the same thing this can do with a port was built into it. So, yeah, no comparison between these two devices. They're very different devices and very different classes. But I think this little FNIRSI thing's actually doing okay for the price it's going to be sold for. So, as always with FNIRSI gear, I do notice there do tend to be like little quirks that they always have. There's always something you're never quite happy with. It's always something. I don't know what it is. They get design and everything really close to perfect, and there's always something that gets missed. I see that with just about everything they do. It's I don't know. It's interesting. It's almost like it's intentional, to be honest. But that's the other thing. It should really have a dedicated earth screw going to the casing for electrical safety. Like I said, these are just little things. You know, electrical safety. I'm just being fussy. Right? It's probably perfectly fine. The chances of this casing coming live is absolutely minute because the actual heatsink is touching it and the heatsink is earthed. If something were to go wrong, there's a good chance, even though there's a small bit of insulation effect from the anodizing, it would still be okay. I think this is kind of floating in a way. It's almost double insulated. I think it's probably fine. I'm just being fussy about that part of it. So thanks a lot for FNIRSI for sending this to me at no cost. Appreciate that. Don't forget to check out the other reviews in my FNIRSI playlist. I've got other things to review here. I've got soldering iron. I've got a LCR meter. So those reviews will be coming out in the next couple of weeks or so. Other links to watch down below there, including that playlist. Subscribe over here and already subscribed. There's a Patreon support link over there if you want to become a Patreon supporter of the channel and donate to it. If you want to help me to buy test equipment to repair and do videos about repairs and things from mailbag and that sort of stuff, then that all helps. It's really appreciated. It costs a lot of money to run a YouTube channel. At least it does in my case. I could buy one piece of equipment that costs a couple of $1,000s easily. Catch you later.